Okay, so today we are solving chemistry, okay, and we want to look at what we call as unit conversions, okay. So we all know that when you're measuring something, okay, that something you always measure it in certain units, okay. It might be length, then you say maybe centimeters, meters, okay. It might be time, you can say hours, you can say seconds, minutes. Might be mass, you can say kg, grams, okay? It might be temperature, where you can say degrees or kelvins or Fahrenheit, okay? So there are a number of units that we use to measure different quantities, okay? So in this lesson, we are specifically trying to convert, okay, a given unit to a stated unit. So before you can convert any unit, there are three things that you have to know. Okay, someone is there, mic and mute, you're getting some background. There are three things that you have to be aware of. Okay, so these three things are: one, you have to know the SI units. Okay, you have to know the SI units. So we have 7 of them, I'll show you. And then two, you have to know the conversion factor. Okay, you have to know the conversion factor of a certain unit to another unit, okay? And this conversion factor, you can easily know them by knowing the third thing that you should know, okay? Which is the metric system, okay? So you have to know, one, the SI unit, the conversion factors, okay? And then you have to know the what? The metric system, okay? So what are the SI units? Okay, so earlier I sent a video on this SI unit. It's also there on the Google Drive. Okay, so for those who watched, it will be like a revision for you guys. So when we talk about the SI units, okay, then we are talking about these 7 here. Okay, so the first one, you have to know that time is an SI unit. Okay, so time is symbolized by a T, and then the SI units for time are seconds. Okay, so take note. And then we have length, which has SI units meter. And then mass, which has SI unit what? Kilogram. We have electric current, which is measured in amperes. Okay, and its symbol there. And then thermodynamic temperature, or we can simply say temperature. Okay, so temperature, most students they get confused. Okay, so the SI units for temperature is not the degrees Celsius, the degrees Celsius that you know. Okay, it's what we call as a Kelvin. Those are the SI units for what? For temperature. Okay, and then we have the amount of substance, which is the mole, which is what you are going to do the most in your chemistry. You'll just be talking about moles, and more moles. Okay, and then we have luminous intensity. I don't think you ever encounter this, okay? But it's measured in what we call as the candelas, okay? And it's for those who are majoring in chemistry, that's why we'll be doing this. So these here are the 7 what? SI units. So you have to know them, and you have to know their what? Their units, okay? So I've shown you here. And then the next thing that you have to know is what we call as the metric what? System, okay? So I know you've seen it before, some of you, others you have not. Okay, so especially those who are taking is it pure physics at grade 12? Okay, you have what we call as the metric system. So the metric system is like a guide that guides you. Okay, so it has symbols, okay, that denote numbers. That's what the metric system is. Okay, so a certain symbol will mean a certain number. Okay, and that has to be in your head. So for example, if you say 1 GB, let's say my phone is 128 GB, okay? So that G in the GB is what we call as the giga, okay? So G, meaning giga, is represented by what? 10 to the power 9. Okay, so wherever you hear giga, chan, gigabytes, whatever gigabyte, just know that the giga there represents 10 to the power 9. Okay, and then we have tera that represents 10 to the power 12. We have mega that represents that represents 10 to the power 6. So this mega is the same as a million, right? So if you can see on Facebook, if a post reaches maybe 100 likes, you see they write 1 capital M there. Okay, so that means 1 million. So that's a mega. Okay, so whenever you see the capital M there, it just means 10 to the power 9, or simply 1 million. Okay, and then we have a kilo, which is very common, 25 kgs ya unga ya milti magura. Okay, so that K in the 25 kgs means 10 to the power 3. Okay, so you have to know the metric system by heart. Okay, so it's not hard to know. Okay, so from the top here going down, these numbers here, the powers, you can see they are reducing by 3, right? Until you reach the kilo. Okay, when you reach the kilo, you have what we call as the hecto. And then that hecto is what? 10 to the power 10 to the power 2. And then we have the deca, which is 10 to the power 1. And then here you put the SI unit. Okay, so here where there is 1 is where we're going to be putting some of the SI units. Okay, and then below 1, we start again. 10 to the power -1 is what we call a deci, okay, represented by a small letter d. And then centi, the thing that you like saying centimeter, whatever, okay, that centimeter, that C in the centimeter just represents what? 10 to the power -2. And then we have a milli, not million, but a milli, which is 10 to the power 3. Then we have a micro represented by this symbol, 10 to the power 6. And then nano is 10 to the power 9. And then pico is 10 to the power 12. Okay. So I remember when I was, I don't know if it's in grade 12 or first year in my university, at a group study, and we made a song using these same things that you are seeing here. Okay, but we are jumping like 1 or 2 of these. But it used to help us to remember whatever we had. So the song was going like, we are starting from below here. So we are saying like pica, nano, micro, midi, centi, deci. And then when we say deci, we were jumping this guy and this guy. And then we just go straight to kilo, mega, giga, tera. Okay, pica, nano, micro, midi, centi, deci, kilo, mega, giga, tera. So it used to help us remember. Okay, so this metric system here is very important. And I'm going to show you when we start solving those questions. Okay, and then the other thing is you have to know the conversion factors. So the conversion factors, you just get used to them. There's no specific way in which you can know them. Okay, you just get used to them. For example, I know that 1 meter is equals to how many centimeters? We all know that it is 100 what? Centimeters. Then let me say if I have 1 kg here, 1 kg is equals to how many grams? We know that it's what? 1,000 grams. Okay, so there are those conversion factors that are common, or maybe I say 1 minute is equals to how many seconds? We all know that it's what? 60 seconds. Okay, so these are some of the conversion factors. And then from the conversion factors that we know, we can come up with any conversion factor that will be needed, okay, in our discussion. Okay, so now let's look at some of these questions, because I've highlighted what you need to know in order to solve any question, okay? So here they're saying, question 6, they're saying convert the following to their required SI units, okay? So remember the 7 SI units that I showed you, okay? So this here is 10 nanometer, okay? Because I can see a small letter n there, so that's nano. So 10 nanometer. So what's the SI units for this quantity here? Anyone who can try? What's the SI unit for this quantity here? Or I can say,
Meter.
Okay, meter, yeah. So why are you saying a meter? Because it's length, right? Okay, so this is length. So we are converting these 10 nanometers to meters, okay? So let's get this 10 nanometers and put it here and then try to convert it. So we have 10, okay, nanometers. And we want to convert this guy to meters because that's the SI unit. Okay, we want to convert it to meter. So how can we convert this? Okay, so if you want, you can use a conversion factor. Okay, so it means you have to know the relationship between a meter and a nanometer. Or you can use the metric system, which is the simplest. So from the metric system, we said nano is equals to what? Those who took note of the nano. Nano is equals to what from the metric system?
10 to the power -9.
Exactly. Okay. So nano means 10 to the power -9. So wherever there's nano here, we're just going to put that's 10 to the power -9. Then we'll be done if you have converted it to the meters. So we are going to say 10. Okay. We can even write times. And then here where there's nano, we are putting the number that represents the what? The nano, which is 10 to the power -9. And then this meters remains. So this is 10 times 10 to the power -9. And we know that this guy here, if we're using some concept of radicals, this guy is the same base as this. So what happens when you're multiplying the same base? You add the powers, right? So if this is 10, it means it's raised to power 1. So we're just going to say 10 and 10, they're the same base. And then we add their powers. So 1 plus -9. So it's just the same as 1 minus 9 meters. So which means here we're going to get what? 10 to the power 8 meters. Okay, so you can include a 1 in front here if you want. You can say 1 multiplied by these meters. Okay, so you can simply convert it like that. Okay, so that's the goodness when you know the metric system. Your conversion will be very simple like that. Okay, and then let's look at B. So if you have any questions, guys, be free to ask. Okay, just unmute yourself and then ask. Okay, so B here.
I've got a question.
Yes, ask.
So in a situation where we don't have the same bases, we're supposed to punch 10 to the power -9 on a calculator.
Okay, no. It's best you leave it in scientific notation.
Oh.
Yes. You leave it in scientific notation. Don't punch 10 to the power -9. If you punch 10 to the power -9 on your calculator, it will give you back the same 10 to the power -9. Unless you're using those odd Casio calculators. It will give you 0.000 and you don't want to write a lot of zeros.
All right. So if, for example, where we've got the 10 there in front before the times, does this mean we just say, maybe, for example, if you've got a 5, we say 5 times 10 to the power 9?
Yes, that's what you say.
All right.
Okay. Right, so let's look at this B question. So this B question is very special because it's a unit that it was there a long time ago and then they changed its name. Okay, but anyway, we can still work with it. So here we have been given 10 angstrom. Okay, so 10 angstrom. So angstrom is used to measure what? Length. And Armstrong has a fixed definition that you have to know by heart. Okay, so let me write it here. So we want to change 20, okay, angstrom to what? To its SI units, which is the meter. Okay, so what are we going to do here? We have to know the definition of this angstrom here. Where did I write like a 0, side? It should be up there. It should be here. Like that, okay? So this one here has a fixed definition that you have to know by heart. So you have to know that 1, okay, angstrom is the same as 10 to the power -10 meters, okay? So by definition, you say 1 angstrom is just a tenth of a billionth, okay? A tenth of a billionth of a meter. That's what 1 angstrom means. Okay, if you can't pronounce that word, you just say 1 angstrom is the same as 10 to the power -10 10 meters. Okay. All right. So here we have 20. So we can use cross multiplication here to convert this to the meter. So we are going to say, what about 20 angstrom? Okay. What is it going to be here? So you put x there, and then you say cross multiply. So this x will multiply with these guys. So we have x multiplied by 1 angstrom like that. Okay, should be on top here. And then this is equals to, I have 20 angstrom, so 20, and then multiplied by 10 to the power minus 10 meters. Okay, so we want to find the value of this x. So we're going to divide both sides by what? 1 angstrom like that. So we see that this one and this one, they will cancel. So we remain with x is equals to, so if we divide this side here by 1 angstrom like this, okay, it means the angstrom here and this guy is going to cancel. So we are going to remain with 20 multiplied by 10 to the power minus 10 divided by 1. So we have 20 multiplied by 10 to the power minus 10 like this, and then meters. Okay, so what do we do here? Okay, we have to express this number in scientific notation. Okay, so the way it is here, is not in scientific notation. Okay, anyone who knows the reason why this number is not in scientific notation? Anyone? Okay, so
we're not allowed to have a number which is like the 20. We're not allowed to have a number which is more than 10.
Exactly. Okay, so this number here that you put here, and then you say times 10 to the power something, this number here should always be 1, should be greater than 1, but less than what? Less than or equal to 10. Okay, so this 20 is greater than 10. So we have to make this 20 to be less than 10. So what are we going to do? We're just going to move the decimal place, because this 20 means it has a decimal point there, right? So we're going to move this decimal place one step to the left. Okay, so we are going to have 2.0 multiplied by 10 to the power. How many times have we moved? We've moved 1 time, and we've moved to the left. So it means the power here should be what? Positive. So it's the opposite. If you move to the left, the power is positive. If you move to the right, the power is negative. And then we have this other thing here that remains. So times 10 to the power minus 10, okay? And then you say meters. So this is what you have here, okay? So this and this have the same power. So we can add, they have the same bases, so we can add their powers, okay? So this is going to be equals to 2.0 multiplied by 10, and then 1 plus minus 10 is what? It's minus 9, and then meters. Okay, so this here, that 20 angstrom that we had, okay, if we convert to meters, it's the same as that number that we are seeing there. Okay, the 2.0 multiplied by 10 to the power minus 9 meters. Okay, so any questions there, guys, before I move to the next question? Okay, let's just look at the next question. So the next question now, they're saying convert 0.5 micrograms to its SI units. Okay, so we know that we have been given micrograms here. So we are dealing with what? We're dealing with mass. Okay, so we have to convert these micrograms to kilograms, because we said the SI units for mass are kilograms. Okay, so there are 2 ways in which you can go about this. You can go the direct way, or you can first convert it to grams and then you convert it to kilograms, which is the simplest way. So we are going to follow that. So we have C here. We have 0.5 micrograms. Okay. So from here, we see that we can use the metric system to know what the value of this guy is. Okay. So micro, what did we say micro was? Micro is what? We said it was 10 to the power what? Minus 6. Okay. So you can check on the metric table. I sent it in the group. So micro is just 10 to the power minus 6. So where there's micro here, I'm going to put 10 to the power minus 6. So this will be 0.5, okay, multiplied by 10 to the power minus 6 in place of this micro, and then grams. Okay, so now we can convert these grams easily to the kgs because we know the conversion factor from the grams to the kg. Okay, so we know that this 1 kilogram here is the same as what? 1,000 grams, or 10 to the power 3 grams. It's the same. So 1,000 is the same as 10 to the 3. Okay, so now we have this number here, which is 0.5 multiplied by 10 to the power minus 6 grams. And we want to convert it to what? To kgs. So what are we going to do? We are going to cross multiply. Okay, so we're going to cross multiply here. So we have 1 multiplied by this guy. So in fact, let me start with the x. So x multiplied by this, we're going to have x and then 1,000 grams. Okay, 1,000 grams. Let me write this 1,000 as 10 to the power 3 to be easier. So 10 to the power 3, then grams, is equals to 1 kg, okay, multiplied by 0.5 multiplied by 10 to the power minus 6 grams. So this is what we have, okay? And we want to find this value of x. So we are going to divide both sides by what? 10 to the power 3 grams. Even this side, we are going to divide by 10 to the power 3 grams. So this here will cancel with this, so we're remaining with x is equals to, okay? So this gram here is going to cancel with this gram. And then I have 1 multiplied by 0.5 multiplied by 10 to the power 6, to the power minus 6, okay? And then I have a kg at the end. So I'm going to write 1 multiplied by this is the same. So 0.5 multiplied by 10 to the power minus 6, and then I'll put the kg at the end. And then I'm dividing this by what? 10 to the power 3. Okay, and then from here, if you want, you can use a calculator, but it's not advisable because a calculator will give you a lot of zeros. So we can just say, let's separate this to 0.5, okay, multiplied by, and then let's put these 10s together. So we have 10 to the power 6 divided by 10 to the power 3, and then we have a kg here. So we see that we have same bases, and then we are dividing. So what do we do when we're dividing? We subtract powers, right? So this is going to be 0.5. Okay, Martha, you are writing on my screen. So this is going to be 0.5 multiplied by, okay, 10. And then here, since we are dividing, so we are going to subtract these powers. So it will be minus 6 minus the power that is down there, which is what? 3, and then kg. Okay, so remember, we have to express this in scientific notation. So this is multiplied by 10 to the power minus 9, and then kg. Okay, so this guy here, we can notice that it's less than 1. Okay, remember what we said about scientific notation. The number has to be greater than 1, but less than 10. Okay, so we have to make this guy here to be greater than 10. I mean to be greater than 1. So what are we going to do? Akim, you are raising your hand. You have a question? Okay, maybe it was a mistake. Okay, so what can we do to make this number greater than 1? We are going to move this point to the right 1 time. Okay, so it means we are going to have 5 multiplied by 10 to the power what? Okay, since we've moved this point to the right and we have moved it 1 time, okay, the power here will be what? To be a minus 1, and then multiplied by 10 to the power minus 9, and then kg. Okay, so it means from here, we're just going to have 5 multiplied by 10 to the power minus 10 kg. Okay, so this is the final answer here. It means you have converted that 1 microgram, okay, to the kgs. So we have converted that 1 microgram. I mean, it was not 1, it was 0.5, right? Yeah, 0.5. 0.5 micrograms per kg. So any questions here? Okay, no questions. All right, so the next one is very simple because it has a fixed formula. So we are dealing with temperatures. So this one and this one.
Sir, I have a question. I have a question on the previous on the previous question you were solving. Yes, like I wanted to ask where you separated 5. Yes, it was 0.5 times 10 to the power something over 10 to the power 3, that one. Yes, when
Okay.
you separate it, doesn't yes,
Okay.
this stage. Does it affect the equation or it only affects it when you are dealing with additional and minus?
Yeah, so when you are dealing with addition and minus, you can't do what I did to affect the equation. Okay, but
Okay.
when you are multiplying, it doesn't. It's the same.
All right. Okay. Thank you.
You're welcome. Okay, so now let's look at some temperature conversions. Okay, so remember I said temperature, we have kelvins and what? Degrees. Okay, we have kelvins and degrees. So you have to know how to convert from kelvins to degrees and from degrees Celsius to kelvin. Okay, so we just use one formula. So this is the formula. So temperature in kelvins is given by the temperature in degrees plus what? You know this, plus 273. This is what we are using at secondary, right? But here we are going to add 0.15. Okay, so this is the formula that you use when you're converting either from kelvins or to the degrees. So it means when you're converting from maybe kelvins to degrees, okay, it will be this, you just make this the subject. So it will be kelvins minus the 273.15, okay? So these conversions here are very important. Why? Because when you reach topics like chemical equilibrium, chemical kinetics, those things, activation energy, thermodynamics, they'll be giving you temperatures in degrees, and then you'll be required to change them to kelvins, okay, before you solve anything. So if you don't change them to kelvins, then everything becomes wrong. So this formula here is a very powerful formula. So the first one here, they're saying, let's convert 25 degrees Celsius to what? To the SI unit, which is Kelvin. So we're going to use this first formula here. So we're just going to say Kelvin is equals to 25 degrees Celsius plus, okay, the 273.15. So just get your calculator and then you add this, okay? And then you just ignore this symbol here. So whatever you get becomes kelvins, okay? So 5 plus this, we punch on my calculator. Okay, so it's giving me 298.15 kelvins. Okay, and we know that this is the room temperature, right? The 25 degrees, the room temperature. So that's how you can convert. So it's not hard to convert temperature as long as you know the formula. Okay, and then the other question at 30 degrees. So to convert, we just put the 30 degrees here, and then we add with this on your calculator, and then whatever you get, that's the value of the what? Of the kelvins. Okay, so I've showed you these formulas here. You just have to know these formulas, then you can convert. Okay. Okay, I don't think you guys will deal with Fahrenheit. I don't think so. So you just concentrate on the kelvins and the degrees Celsius. Okay, and then we have another question which is on okay, someone is saying, okay, so Akim, I'm going to share the video when we are done, so you can watch the part that you missed. Okay, so now let's convert this guy here, which is the time. Okay, let's convert the time. So I've been given 24 hours, and then we're asked to convert to its what? SI unit. So that is the SI unit for time. The SI unit for time is just the seconds. So we have to convert that 24 hours to seconds. Okay? All right, so it's very simple. It's just a step by step. Or if you want, you can even go direct if you know the conversion factor. Okay? So we have 24 hours here. and you want to convert this to what? To seconds. So there's a formula, okay, a direct conversion factor that says that 1 hour is equals to 300 and 600 seconds. We can use that, okay, it will just be direct. Or if you want, you can convert the hours to minutes, and then you convert those minutes to seconds, okay? It's the way you want it, okay? So that conversion factor says 1 hour. 1 hour is equals to 3,000, okay, 600 and, okay, 3,600 seconds, okay? So this is the conversion factor from hours direct is what? To seconds. Okay, so we are going to use this one here. So we are just going to say 24 hours and then X here. And then we cross multiply here. So X multiplied by 1 hour, you're going to get X 1 hour. Okay, and then this will be equals to 24 hours multiplied by 3,600 seconds. This is what we have here. Okay, so just divide both sides by 1 hour. Even this side, you divide by your 1 hour. So this 1 hour, this 1 hour will go. We are going to remain with X is equals to this hour will cancel with this hour. So we are remaining with 24 multiplied by what? 3,600 seconds. Okay. And we can run the value here. So just punch on your calculator to get whatever value you're going to get. Okay, so this is equals to, my calculator showing me 8,640 seconds. Okay, so that's 24 hours here is what? 86,400 seconds. Okay, so that's how you do that. So I don't know if there are any questions there. Okay, so there are no questions. Okay, so just know the conversion factors, guys, and the steps that you have to take. Sometimes they can give you convert 2 days to seconds. Okay, so what are you going to do in that case? You're first going to convert those days to the hours. Okay, and then once you have your hours, you can use this conversion factor that we used here. Okay, well, first you can convert those hours to minutes, and then those minutes to seconds. Sometimes they can even ask you to find the milliseconds. Okay, so you just knowing the metric system and the what? The conversion factors that are common. Okay, all right, so that's that on time. And then let's look at this one here. So they're saying convert the following as stated. Okay, so here now we are given 2 units that are dividing each other. We are converting 1 gram per centimeter cubic to kilogram per meter cubic. Okay, so here you have to listen carefully. So we have this here. So we have this guy 1 gram per cubic centimeter, and we want to convert this guy, okay, to kgs per meter cubic. So we have 2 sets of units here. Okay, we have the one for mass and we have the one for what? Okay, what is this, guys? What's the quantity, this one here? Or this one? Come on. What's the quantity? No, it's not length.
Length.
No, it's not.
Length.
It's not length.
Volume.
Okay. Yes, okay, it's volume because there's a power 3 there. So it's
volume.
Yes, correct. So it's volume. Okay, so this is density, guys. When you are at density, you are dividing mass over volume. This is density. So we want to convert 1 gram per cubic centimeter to a kilogram per what? Cubic meter. So what we have to do here is to work with the 2 units that will be. But first of all, okay, we have to know the conversion factor, okay, of the gram to kilograms and of these